We have a rocket starting from rest. U is 0, T is 3, S is 27, and we've asked to find A. Formula we're going to use, S equals UT plus a half A T squared. So 27 equals 3 times 0 plus 1/2 times A times 9. 27 is 9A over 2. So 54, 2 times 27 is 9A. A is 6 meters per second squared. Okay, in part B, we're asked to find the speed of the rocket after 3 seconds. U is 0, V we're trying to find out, A is 6, and we know that T is 3. So V equals U plus AT. V equals 3 times 6, 18 meters per second. We now have a new situation. The rocket is not acting under any forces, it's only acting under gravity. So from here on, our acceleration will be minus g, which is minus 10. The speed at 3 seconds, the 18 meters per second, becomes our u. And we're asked to find the height of the rocket above the ground 5 seconds after. So we're interested when t equals 2, and I want to find s. So S equals UT plus a half A T squared. So it's 18 times 2 plus 1/2 times minus 10 times T squared, which is 4. So the displacement is 16 meters. We now need to combine our answers. After in the first 3 seconds, so from 0 to 3, it travelled 27 meters, and from 3 to 5 it travelled 16. So its total height off the ground will be 43 meters above the ground. Question 2a, we have a velocity time graph. Distance covered will be area under the graph, so I'm going to sketch that out. And I'm going to go with the trapezium. If you want, you can split it into a triangle and a rectangle. The length along the top is from 4 to 20, so that is 16. Length in the bottom is the 20 seconds, and the height of the trapezium is 9. The distance travelled, the area is half the sum of the parallel sides times the distance between. So it's a half times 36 times 9, 18 times 9, which is 162 meters. B, I'm going to use the equations of motion to find the value of u. It's going to get a little bit confusing, so because we normally use u as the initial velocity. In this case, our initial velocity is 9. Our final velocity is u. The time is 5. The race total was 200 metres, and we've just worked out that they travelled 162 in the first section. So my S for this section will be 200 minus 162, 38. I'm going to use that S equals U plus V over 2 times T. So 38 must equal u plus 9 over 2 times 5. 76 equals 5 upon u plus 9. 15.2 equals u plus 9, so u must be 6.2 meters per second. Final part, I'm going to use the equations of motion again. Initial velocity 9, final velocity is 6.2. The acceleration we're trying to work out, and the time is 5. So V equals U plus AT. 6.2 equals 9 plus 5A minus 2.8 equals 5A. So A equals minus 0.56. We've got to be careful in the question. We're asked for deceleration. So the deceleration is 0.56 meters per second squared.